Hello, and welcome to the lesson on multiplying and dividing rational expressions. So, our last lesson that we went through was simplifying rational expressions, which laid the groundwork and basics for this lesson. So, please make sure that you take care of the simplifying rational expressions lesson before moving into this lesson. So there's three steps that we're going to look at for multiplying and dividing rational expressions. Step one is to multiply the numerator and denominator. So not cross multiply diagonally, just across the top, meaning numerator times numerator, denominator times denominator. So multiply the numerators together and the denominators together. We're not doing any diagonal multiplication. Then for the second step, we just factor, and we're dividing out common factors from the top and bottom. And after we factor, we do that final step of making sure our answer is fully simplified. So let's look at our first two examples here, A and B. So the first thing we need to do is multiply numerators and denominators. So on top, 2x to the third times 15x to the fourth. 2 times 15 gives me 30. X to the third times x to the fourth is x to the seventh. On bottom, 5 times 8 is 40. X to the fifth times x squared is x to the seventh. So I'm looking for what I can divide out from top and bottom. So 30x to the seventh and 40x to the seventh both share x to the seventh and factors a 10. So if I divide top and bottom by 10x to the seventh, I'm left with 3 over 4. In B, we have 3y squared times 16y to the fourth on top, which gives us 48y to the eighth. On bottom, that should not be a y to the eighth. That should be a y to the sixth. I just looked at that. So this answer is actually going to be different because that would be a 48y to the sixth, not to the eighth. So that should be a 6 here, not an 8. Really bad looking 6. So that's a 6, not an 8. So we have 48y to the 6 over 40 or over 36y to the eighth. So 48y to the 6 over 36y to the eighth when we multiply across top and bottom. So then we're looking, what can we divide out? So in this case, I can divide out a 12, 48 and 36, both can be divided by 12, and a y to the 6. So in this case, if I'm canceling out the 12s and canceling out y to the 6, my final answer would be 4 over 3y squared. And the bottom is still a y squared because the y to the eighth, if we're getting rid of y to the 6, we'd be left with y squared. So that should be 4 over 3 y squared. All right, moving down to C and D here. In C, we have 3x times x minus 2 on top, and on bottom, 2x squared minus 4x times 3x squared plus 5x minus 2. So here's what I did first. On top and bottom, I'm just going to write it out as multiplication, meaning 3x times x minus 2 on top. And on bottom, with the 2x squared minus 4x, that can factor to be 2x times x minus 2, because I can divide both parts by 2x. So undoing the distributive property, this part here became 2x times x minus 2, and that's still being multiplied by this trinomial here. The reason I wrote it that way is, before I multiply, now I can cancel out the x's on the outside from the 3x and 2x, and I can cancel out the x minus 2's. So now I'm left with 3 over 2 times that trinomial 3x squared plus 5x minus 2. Now, because the goal is to simplify in the end, I'm going not to distribute this 2 to each part, because I'm just going to have to undo that. But what I'm going to do is to factor this trinomial. So 3x squared plus 5x minus 2 factors to 3x minus 1, x plus 2. So our answer here would be 3 over 2 times 3x minus 1 times x plus 2. Now, could you technically write that as 3 on top over, and then distribute this, so it would be a 6x squared plus 10x minus 4. That piece right here would be if I had to multiply the 2 times this, times that, and times that. Technically, this is the same thing as that. This piece here on the left is just more broken down or more simplified. Now, if we look at D, and again, you'll see in D that I break it down to different factors, and then I do any sort of simplification. So rather than actually multiplying the top and bottom, I just write them next to each other. So when I'm dealing with this complex of factors, I just write them next to each other, which means multiplication. So I have x squared minus 16 on top times 2x squared minus 5x minus 3. And then my bottom is 10x squared plus 5x times 4 minus x. So if I just break all those into individual factors, x squared minus 16 breaks to x plus 4 times x minus 4 when we factor it. Difference of two squares, so that comes from the x squared minus 16. Then factoring 2x squared minus 5x minus 3 gives me 2x plus 1 times x minus 3. And then if I do my factoring on bottom, the 10x squared plus 5x, I can factor out a 5x. So I have 5x times 2x plus 1. And then my 4 minus x, if I factor out a negative 1, that becomes x minus 4. So the reason I did that, now you can see I can cancel the 2x plus 1 on top and the 2x plus 1 on bottom. I can cancel the x minus 4 and the x minus 4. So then I'm left with, on top, x plus 4 times x minus 3. And then on bottom, the negative 1 and the 5x, so a negative 5x. And that would be our simplified answer. So then in E and F, 8x over x squared minus 7x plus 12 times x minus 3. So I write the x minus 3 over 1, just to remind myself any whole number is a fraction over 1. Then on top, I have 8x times the x minus 3. And on bottom, if I factor this trinomial here, I get x minus 4 times x minus 3. The x minus 3's cancel out, so I'm left with 8x over x minus 4. And then last example for our multiplication is f here. 4m squared times 6m plus 18 on top. And then on bottom, 3m squared plus 9m times 2m squared plus 3m minus 2. So I just write it all together as one fraction. And then I factor the top and bottom. So 4m squared times, and I can factor out the 6. So 6 times the quantity m plus 3. And on bottom, the 3m squared plus 9m, I can factor out a 3m. And I have 3m times m plus 3. And then this trinomial factors to 2m minus 1 times m plus 2. So then in that case, I can start to cancel pieces that are shared. So m plus 3 and m plus 3 cancels. And from my m squared and my m, that could be canceled down to just a 4m on top and the 3 on bottom. So now what I have is 4m times 6, which is 24m on top. And on bottom, 3 times 2m minus 1, m plus 2. Now the 24 and the 3 can both be divided by 3. So that becomes 8m on top. And then the 2m minus 1, m plus 2 on bottom. Now, the same rule applies to rational expressions as it does to dividing fractions. The easiest rule to keep in mind is not to divide out fractions. All right, so if we look at how to do the multiplication or the division as multiplication, so what we want to do, again, is if it's division, change it to multiplication by multiplying by the reciprocal, which simply means flip the second fraction. So just like a normal fraction, we multiply by the reciprocal. So if I look at a, I have n plus 7 over 4n divided by n plus 7 over n minus 2. I flip my second fraction to become n minus 2 over n plus 7 and change division to multiplication. So now my n plus 7 on top and bottom cancels, and I'm left with n minus 2 over 4n. In B, again, division problem, so change division to multiplication, flip our second fraction. So it becomes 2n plus 3 over n times n plus 3 over 2n plus 3. The 2n's plus 3 cancel, so we're left with n plus 3 over n. In C, we have x squared minus 36 over 4x squared divided by x minus 6 over 1. So I need to flip the second fraction, becomes 1 over x minus 6. On left, if we factor the top, x squared minus 36, difference of two squares, x plus 6, x minus 6. On bottom, we still have the 4x squared. So then we can cancel the x minus 6 here and the x minus 6 here. So we're left with x plus 6 over 4x squared. Now in D, we have 3x over x squared minus 2x minus 24. So if I just factor that part, on bottom, we have x plus 4, x minus 6. Now on the right, we need to flip that and change it to multiplication. So the x minus 6 comes to the top. And then factoring the 6x squared plus 9x, I can divide out a 3x. So I have 2x plus 3. So in this case, what I can cancel, x minus 6 and x minus 6, 3x and 3x. So I'm left with 1 over x plus 4 times 2x plus 3. And then our last two examples, E and D. So again, we're going to flip the second fraction and change it to multiplication. And then we factor both top and bottom of each. So factoring the left here, 2x plus 4 is 2 times x plus 2. 5x squared minus 15x is 5x times x minus 3. On the right, after we flip it, the 10x minus 30, factor out the 10, so we have 10 times x minus 3. And 4x squared plus 8x, factor out the 4x, and we have x plus 2. Now, x plus 2 on top, x plus 2 on bottom cancel. X minus 3, top and bottom cancel. So on top, we have 2 times 10, which is 20. On bottom, 5x times 4x, which is 20x squared. The 20's now cancel, and we're left with 1 over x squared. And then our last example for this lesson, in f, x plus 1 over 3x cubed minus x to the fourth. So we could factor out on bottom the x to the third, leaving us with 3 minus x. On the right, we need to flip it, change it to multiplication, and then factor. So x squared minus 3x can pull out an x, so that would leave us with x minus 3 over 5. The x here and the x to the third can be simplified down to cancel out this x and leave us with x squared. So the bottom is simply 5x squared times 3 minus x. On top, we have x plus 1 times x minus 3. Now, I can get my x minus 3 and 3 minus x to cancel by factoring out the negative 1. So then I'm left with x plus 1 over negative 5x squared. So what you want to keep in mind for the steps today, multiply denominator and numerator together, factor and divide out your common factors or cancel them, and then to simplify.